Hello everybody! Welcome to the stream. It's me, your host, Godo. I'm just doing a usual sound check before starting, just to make sure that everything is fine and dandy. Okay, I'm gonna put the music just a little higher because it does seem pretty low, even though it's some pretty calm songs that I've got playing. Maybe like this? Yeah, that should be better. That should be better. Let me just hear in my second device to make sure. Okay, yep. That seems just fine to me. So without further ado, let's start the stream. You guys should be hearing much less ambient noises than the previous two streams. The reason for that is because I turned back on my filters on OBS. I will not be, making like keyboard ASMR too much today. So this is why I put my filters back on. I didn't feel like, we're going to be programming a lot more. And I don't think you guys want to hear my old keyboard all that much because the sounds aren't quite as satisfying as my new one, the one we're actually going to be programming. As you can see on your screen, there's a little post-it with the objectives for today written, or at least, this should really cover everything that we're at maximum going to be able to do this stream. I don't think we're going to get there, but we'll see. So today we're starting with the firmware of the keyboard, fully custom keyboard. So what we're going to be doing is, at the very least, trying to make the code run on the Raspberry Pi Pico. So first off, we're going to just test the debug LED, make sure that it works. Then we're going to be testing using the debug LED basic button presses, at least one or two buttons, we're going to test, make sure they work. Then we're going to do some basic USB communication with the computer. This way we're going to be able to send information to the computer. We're probably just going to be writing one letter like a T, perhaps. We're just going to be sending a T when we press the correct button, just to make sure that we're able to, actually send information to the computer, right? That's the whole point of a keyboard. You press keys and then you say, hey, those keys were pressed. Please print something on the screen. So that's like the very basics of which we're going to be doing today. And then we're going to be starting with the input system, which I call inputs to events. So we're going to take the actual key presses on our custom keyboard and see how they're pressed through time. Using, that, we can actually extrapolate more advanced events, right? So if a key is being held, if a key has been released, if a key has been pressed, instead of is it just currently pressed, and that kind of events, right? That's what I call events. They're kind of advanced inputs, you could say, or inputs that have been processed. So we're going to get hopefully up to there today. We're going to see. It depends with, what's my proficiency putting code on the Pico. I used to be pretty good at that, but it's been months and months. As I said, it's a project that I technically started doing the research for and some trial and error on my own side a very long time ago. So it's been a while since I've been back to the code for it. Back in the day, I was using a breadboard. Now we actually have a real system. Speaking of which, I'm just going to show you guys what we saw last time. So as you can see, I also soldered the connector here. I soldered it to the microcontroller. Now there's just a little problem that I noticed. I did try to put the cap on and then remove it. And I noticed that some of the solder did disconnect. So I already heated up the soldering iron. So we're just going to be doing some touch-ups right now. It's not going to be long because the mapping is very simple now. I can just see what's connected where. It's going to be really quick. But we're going to have to resolder some solders that were a little too weak, perhaps, before I can actually close it off for once and for good. And I'm happy I could show you guys the connections. These, by the way, they're a lot more flexible than these. So the grid here is a lot more rigid than these wires. These wires, the thing is, because they connect the two parts of the keyboard, like the case and the plate, it's kind of necessary that they're a little longer and that I can kind of like squish them. You know, they can wrap around like here and whatnot when I'm putting the cap on. Yeah, because they're connecting two parts. So when I disconnect, I need there to be a little bit more of a wiggle room, which is how I can open it so much. The rest, they're kind of in place, which is good because it makes for the plate to be like a single piece of electronics all connected together. Now, as I said, there's about 3 or 4 connections that disconnected that I'm going to have to put back on. So it's going to be a little bit more complex. But towards the end of the previous stream, which was a soldering stream, and even a little bit after the stream where I fixed what was left, like these things, I'm actually pretty good at soldering with my equipment now. I'm kind of used to my soldering iron and whatnot. So yeah, it's been a couple days for me, almost a week since last stream, but I should still have the hang of it pretty much. It shouldn't take too long to just do all of these little connections that are missing, and then hopefully close up the keyboard, or at least that half keyboard, for once and for good. You know, just I really hope that I won't have to open it again. So let me just get into it really quick. It's gonna take very little time. Oh yeah, also I put back my mic in front of my computer. So the computer is, you guys, it's like this way. Oh, this way. So yeah, as you probably heard, when I'm soldering and when I'm facing my soldering iron and like this little table, I'm kind of like 90 degrees from the table where my computer is. So I'm a little bit ways away from the microphone. So I can't really talk all that loud unless I'm like I'm doing right now, kind of putting my face away a little bit. Like my face is there right now. So yeah, I kind of have to go back and forth from and to like this table right here if I want you guys to be able to hear me correctly. So I might be a little more silent while I'm soldering. It shouldn't take too long. I just did something stupid. I'm having a hard time. I fused 2 wires, and now I'm having a hard time disconnecting them. Okay, it works. Seems kind of solid. Oh boy, there's gonna be a tough one there. Okay, another one done. I made another mistake. Getting harder and harder. Oh, by the way, you guys can't see. Maybe that's a little better. Okay, I made a mistake here. I think I did some pretty deep soldering between two of the connections. This one and this one. So I really need to fix that issue before I can finish this. I might have to just scrape it off. Okay, I think they're not connected anymore, so I'm just gonna use my multimeter to measure. Okay, that should be fine. I don't think they're connected anymore. So now I can resolder the wires that go there. And then there's just this little connection that sends current to these three switches. So it's the only things that I like 4 solder, basically. 4 solder points. That's what I meant. And then we can go to the firmware. Okay, and now I just need this little wire that just fell. I just noticed something disconnect. Something else that. Oh my god, there's so many things that are disconnected. It's crazy. That was a surgical solder. Okay. The thing is, the little wire that's disconnected is gonna be kind of tough. I'm gonna change the settings on this webcam because it's crazy. There's too much light. Properties, please. Brightness. Can you just have less brightness? Or is it? No, wait. Go back for the brightness. I think it's the exposure that's too long. Oh, no, auto. Okay, that's better. That's already better. Yeah, I think it's better. Also, why is focus auto? Okay, yeah, that's good. Like this. Okay, that's fine. Okay, that's better. So I just need to. The thing is, this is one of the connectors for the power. And the power, the little power grid is under all of the big wires that go directly to the pins. So I need to find, like, I don't even think I can place it where it was, which was from here to there. I think it's gonna have to be from here to there or something, because it's just, I don't even think I could insert it back in place where it was. So I'm gonna find a way, like, as long as current goes there, it's fine. it doesn't work. Okay, I did have. I'm gonna need more solder on the second. Seems to have worked. I think all the solders are okay now. So we should be at a point where we can close it off, connect it to the computer, and start uploading code to the microcontroller. So let's try to close it off without destroying any of the precious solders we just did. Okay. Nothing seems to have completely broken. Okay, and now fully clicked in. It should be fine. I'm not hearing any sounds when I'm moving it, so everything should be in place. And we should be able to connect it to the computer. Nothing should, catch on fire or anything like that. And I should be able to put some code on it and we can start writing our own. So give me a quick second. Oh, I connected the webcam where I was gonna plug this in. Okay, give me a second. Okay, so I plugged it in behind the computer instead. So right here I have the wire as well as the microcontroller. I can plug it in. We can see. Oh, you guys can't see that. What? I tried this. That's way too dark, but maybe I can. Give me a sec. You can probably see the little light now. Yep. I wonder if I can bring the webcam down so that you guys can see better. Also, I'm gonna put back on the light. So maybe I'm just gonna tweak the settings a little bit, but let me just bring the webcam closer to the keyboard. And I'm gonna put some light back on so that you guys can see. Back. More brightness, yeah. Might look a little weird. Maybe more exposure, perhaps. Yeah, that's a little weird, but you know. Oh, it's not too bad like this, actually. So less brightness and more exposure is actually better. Yeah, okay. But anyways, I'm going to be showing you guys the code in just a sec anyways. But here we have a little cam where you can see the keyboard and the keys themselves. Focus is not... Oh, the focus is not good. Yeah. That's what I need to adjust now. So focus. Oh, I had it. Oh, hey, now it's pretty good. So you guys can see from up close. So the light here on the microcontroller. Whoop. I'm hiding with my hand. Yo, my hand looks so big like this. I have very small hands too. So you can see the light is turned on. So it was the previous code that I had on this microcontroller. I don't even remember what that was. It was a test that I had a long time ago. So now, let me just configure something up where I can show you guys both my computer screen and the webcam. So I already have like a view like this. Whoops, why is it moved? Like this. Okay, sorry. So I have this, but I feel like the view of the webcam is not great like this. So maybe I'm just gonna do something like this, but then like, I don't know, add the webcam or something. Like, what if I add the webcam here and make it, no. Put it on top, except the webcam, I can make it a lot smaller. Something like that. And I don't have to show everything. I can just show like what I'm going to be pressing basically. I can put it even smaller. Yeah, something like that, so it's not too disturbing. It's just gonna hide part of the console. You know what? Even the top of the console. Actually, you really don't need to see that. Because you can still see what I'm gonna be writing in the console, like right here. You know, if I write, I don't know. Whoops, not this. If I write like a hello to the console, you guys can see. And you can see the code itself and whatnot. Okay, so that's pretty good. You guys can see everything that matters. And here, whoop, whoop. When I press, you guys will be able to see as well. So maybe I just put it down a little bit so you guys can see a little better. Okay, that seems pretty good. So now let's get right into it. First off, I think I'm gonna have to short circuit a certain pin. Okay, if I show you guys the pins on the microcontroller, just for a quick second. So the pins here, you know, we have the two views of the microcontroller here. So the pins here, there's a run pin here, right? This one. So quick tip, if you are going to do just like I am going to do right now, and you're going to be writing a lot of code and re-uploading new code to your Raspberry Pi Pico very often, maybe it's better to be able to send code to it more easily. Because usually what you have to do, if I'm not mistaken, it's been a long time since I did that because it's slow, but I think that what I have to do if I want to send new code or put the Pico in like receive mode to receive new code is I have to press the button right here, the little white button under the LED. I have to press it while I'm is it while I'm disconnecting or while I'm connecting it to the computer? So let's just try it. Oh, see? The light is not turned on anymore. And I don't know if you guys heard. I think you did. Oh yeah, and you can see the messages and whatnot. So basically, I'm receiving messages like, oh, there's a device that's been connected through USB to the computer. So now the Pico is actually, it doesn't run any code right now. It's ready to receive new code. I think if I press the button again, the white button, or if I wait long enough, I think it's just going to go back to the code that, you know, was already uploaded to it. Let's try. I'm not too sure. Yeah, maybe not. But if I wait long enough, I think it's just going to get back to the code that I already uploaded. But now I could just send other code. I did make myself a quick, I'm on Windows, so I use .bat files when I want to upload code. So I did make one for myself that's very simple. So if you follow pretty much any tutorial or the basic tutorial for the Raspberry Pi Pico C SDK, they're going to help you to set up your CMake list files to be able to send code to your Pico from the computer. Okay. I did write a little script here that would do the three commands that I need to connect the Pico correctly to the computer. So just to be sure, D is that one. Okay, so yeah, it should be E. Oh no. Oh, that's the one. Ooh, so it's actually device D in this case, not E. So I can change the script or something like this. Yeah. Is it because usually I have a USB plugged in or something like a? Okay. Well, it doesn't really matter. It's gonna be device D currently. So, anyways, it's not. Well, I'm gonna leave it like that because it's not this test that I want. So basically, this is a project that I had. I have a bunch of what I call modules with a bunch of code in them where I can test different things. And I have, for every single module, I have a test. So the test is a main, like the most minimal main that can actually help debug it, basically, right? Just make sure that it works. So it's kind of like to test each of my modules individually. And yeah, basically in each of them, I just copy my default clean, which is just to like clean the build files that have been built from this test project. Yeah, the main. I have the CMake list, which I can copy and modify. Usually I just keep it the same because I just have one main.c and that's it. I have a do.bat which does the build, you know, CMake build, it gets everything ready. Then CMake --build, which is what the Raspberry Pi Pico SDK uses to compile the project. And then install is basically, as you can see, it's just a copy command that sends the code, the compiled UF2, in fact, which is like the executable. It copies it to a certain drive. So in this case, E, because when I was programming, this drive was drive E. I probably had another drive connected. Now it's drive D, not E. So I would have to adapt all of these, make sure that everything works. But basically, now we should be able to send any code from my test projects, and it should work. The thing is, my test projects, they assume a certain disposition of the... Basically, they assume a certain circuit that's being plugged into the microcontroller. Because now I have my own circuit, I'm probably better off doing my own test project. So let's take, you know, test LEDs. Wait, what is LEDs here? It's LED, OLED strips. Ooh, no, okay, that's way too complicated. Oh, pin helper, right? Is it in pin helper? Oh, debug LED. Test debug LED. Okay, that's the one. So this one, I can probably, so I'm in the folder Pico. So if I go in the folder, you know, test debug LED, whoops, like this. So I just go in there and I just write do.bat should run. And if I'm not mistaken, yeah, one file copied. So now the code should be in the Pico. Oh, and you can see the LED is blinking now. So in my project, I initialize stuff. I debug LED init, which is part of my debug LED here, debug LED init. So I activate the GPIO, general purpose input output pin that is connected to the debug LED. So if we go back to the little schematics here, as you can see, LED GP25 is actually the debug LED that's right here. So it's one of the things that you get to know when you practice a little bit writing code for the Pico. Just give me a sec. I'm just gonna make sure the music keeps going. Okay, and yeah. So basically, oh yeah, and I have a cooldown since last update and whatnot. So basically, there's like a whole... The code for this project like handles the like debug LED update and whatnot. So basically, what we do here in the main is just that, you know, we loop. Every time that we loop, we remove some amount of time, the amount of time that was spent since the last, let's say the last step or the last frame. And then we remove that from the cooldown timer of the debug LED, where we set the interval to, you know, a full second. And anytime we just, the interval has been reached, then we, yeah, debug LED update. Okay, so yeah, in the update, we check the cooldown, and for the cooldown, we actually like switch the state of the debug LED. So as you can see, it makes for 1 full second, it's on, 1 full second, it's off. Okay, that's really just one quick test. Now we're actually going to be copying the code of this project. So just this entire test, we're going to do Control-C, Control-V, right? And this one we're going to rename, and it's going to be test, I don't know, test button, okay? Just test button. In fact, usually the tests are more like unit tests for my modules. So let's just write project, okay? Just project button. So project is when I know it's just me fooling around, basically. Kind of like, you know, business code, not test code. So here, Okay, so yeah, we're including debuglet and whatnot. That's fine. We like the debuglet, I guess. Do we want it to blink? Maybe we don't update. Okay, let's just try. I think if we don't update, it's just gonna, you know, the init is just gonna turn it on, and then it's never gonna get turned off. I think that's what's gonna happen. So we don't set the interval. Oh, or was there? I think there was a condition where if it's 0. Oh wait, so let's state equal true. Blink is disabled. Oh, so if not, update cooldown timer. Yeah, if not, update cooldown. Return. Oh, because the cooldown timers have the code for that. Okay, yeah. Basically, I think if we put 0 for the cooldown here, I'm pretty sure it's not gonna blink at all. It's some code that I wrote a long time ago, but even with the update being there and whatnot. Okay, so what if I try this code? So here I have a do.bat. I should be able, okay, so here, cd back, and then cd project button. Okay, so now if I, oh, right, okay. So the next thing I wanted to do is, because I'm going to be uploading code very often to the Pico, as I was saying earlier, here, run, if you send current there, so basically like 3v3 out, if I, okay, yeah, you guys can't see. If I send from 3v3 out current directly to run, by, for example, connecting both of these with like a crocodile crimp. That's what I'm going to do. When I press the button right here, the boot button, it's already going to be ready to receive new code. So I don't have to like unplug and replug the micro USB connector, right? It can just stay connected. I just have to push one button and that's it. So this is what I'm going to do. I'm just going to connect them both. So now I have to find pin 30 without making a mistake on my my actual Pico right here. So let me just count. So the square one, so the third one here, it's a ground. Then 2 under that is the 3v3. Okay, the 3.3 volts. And then after that, there's like 3 more before ground. The grounds are pretty easy to recognize because they're squared here. Kind of tough to see, but you can see it. And then 1, 2, and 3 from there. Okay, I'm gonna try to... Okay, I think I got the right ones connected. So let's just try. If I press the white button on the Pico now, it should get ready to receive code. And after that, I only have to send my little command, which is do, and it should just send the code on the Pico. Ooh, it doesn't seem to be working. Okay. Maybe I just connected the wrong ones. Or maybe I can just go with V6 instead of pin 30. Oh, do I have to run pin 30 to the ground instead? Oh, maybe that's it, actually. Yeah, let's try that. Oh, it is that. Okay. Yeah, okay, I remember in the examples, they recommend using a button. I think it's because when you run the run to the ground, basically the pin 30 here, when you send it to the ground, I think the Pico is just not operational while that's happening. So let's just send the code just to make sure that it does what I think it will do. No, it doesn't seem. Well, anyways, I'm gonna use crocodile crimps, all of my crocodile crimps, to like connect a button to the run instead of so basically just another switch that I have lying around. I have a bunch of switches. I can use one. I can use one. Give me a sec. Let's use the oil. I'm gonna give more exposure to the webcam. I think it's too dark again. Yeah, I think that's better. I mean, it might be a little too much. This might be better. Okay. Sorry if it makes a lot of noise. Let me just hear just to make sure it's not too annoying for you guys. Okay, there's a little problem that I'm noticing here. Oh, I understand. No, but it's still... I did set the interval to 0. Why does it not work? What if I do this? I'm in project button, right? Yes, I'm in project button. And the CMake list here. I mean, it should recompile. That's weird. Okay, let's try again. Oh, wait. Okay, I have to do it in the correct order when I press the buttons to reset the Pico. Why just one file copied? It's not recompiling. Does it not realize that it needs to recompile? Maybe I have to clean. And then do. Should send the code. Oh, what? Oops, sorry. So the parameter is incorrect. Generation of make failed. Make command was Pico project button and people system cannot find the file specified. Yeah, but why? If I do clean, let me just try clean. Okay, yeah, there's no okay. And when I do I cannot find the file specified. Whoops, not this one. Is it? No, yeah, it exists. So here in the build, did something go wrong in the build? Oh yeah, it seems so. Why doesn't it build correct? That's the question now. Not sure, quite frankly. I cannot find the files. Yeah, okay. That's the actual error is before. Build. The parameter is incorrect. Okay, why? Maybe here? -- CMake utils. CMake utils, yeah, it's right there. Yeah, okay, that should be fine. Then what else? What's wrong with my CMake? There, yeah. All of these, okay. Yeah, okay. Pico extras, yeah, that's cool. Auto set URL is like, okay. Kernel base, per macro examples with such URL. Oh, yeah. That's all from the examples here. The Pico SDK examples. Wait, do I still have this? I could check. Program files. x86. New ARM embedded. Build chain, yeah, okay. 1021, yeah, okay. Yeah, that. Oh, bin, yeah. ARM9 objdump.exe. Yeah, it should really be there. Yeah, it's there. See, that's always a problem. Making sure that you can actually compile code. Oh, why are you building for Ninja though? Okay, yeah. So here in Pico, there is Pico SDK. Yeah, I have it. Oh, is it because I don't have Pico extras or something? Okay, what if is it like this? Yeah, okay, so Pico extras. Maybe I don't have it. Maybe I do this. Okay. What if I go ahead and do now? Unable to find program corresponding to Ninja. Okay, sure. Program is not set. Probably need to select a different build tool. Yeah, okay. But did I... So... Find a build program corresponding. Yeah, okay, but that's not the one that I want. If I do... CMake configure, maybe? Maybe I want to use... This one or something? I'm not sure about that. And if I do now? I don't know. It's still trying to go for Ninja. I think it's because of my environment variables. Wait, I'm going to show you guys only this for now. Because I don't want to show my environment variables to everybody. You never know. Okay, so the CMake generator. Let me do some quick research. So kind of annoying, the generator thing. Maybe... Okay, I'm gonna try something. Okay, let me try doing it now, I guess. Oh wait, yeah, it's true. I have to, okay, close and reopen. Like this one. Oh. The second I can upload code to my Pico, things are gonna go so fast. Okay. That's really the problem. So the problem is not this. I don't think it is. The problem is about my CMake generator or something. Now, how do I... Okay, let's stop the music for a second. And we're gonna be watching a nice YouTube tutorial where we're gonna be... I don't know if this one is gonna help me, but I hope.
Back in 2021, the Raspberry Pi made the
Oh boy. Okay, I can't hear anything. Because the sound is a lot stronger for you guys than it is for me. Yeah, that's cool. Yeah, that's not what I want. But I do have this though. Is that the Pico SDK path? Yeah. I mean, if I go in my... I'm just gonna put this on my second screen. Uh, Pico SDK path. Yeah, it should be fine. It really should be fine. Now, download the firmware. Blah blah blah. Directory run CMake and make their... That's weird. Yeah, so it's really trying to get Ninja. I know that on this computer, for a different project, I used CMake and I did configure Ninja as the default generator, which is why I had a environment variable about that. But I did remove it, so I don't know why. I don't know why it's still the case. Is it because it's on the path? That's what I'm trying to find. To find select a different build pool. Oh, is this? Oh yeah, that's probably not what I want here, right? Country kids or something. Oh, that's the one. Is that just it? Oh, I think it is. Did I succeed? Okay, let's try. What view did I give you guys? Oh, no, this is the normal view. Okay, so now I'm gonna put the Pico back into a mode where it can receive code. And then I just send code. Come on, terminal. Do? Please. No? Oh, really? Oh, wait. No, it's true. I need to restart VS Code every time I change the CMake configurations. That's true. I think I remember that. So, it just reopen. What? No, not like this. Just Pico, please. Yeah, okay, that's why my setup was not correct. Okay, and now. Come on. What does it look like? If I do, come on, please. Do is not, oh, because I'm not a, okay, CD project, come on. Project button. Also, my Pico is not. Okay, now, come on, let me do it, come on. The parameter is incorrect. Oh, okay. So do build, oh, come on. No, why Ninja again? Oh, is it because I'm not building like this? Oh, but it's set up? Yeah. No, it's not set up correctly. I really wanted to do it from command line. Yeah, that's not really what I want. I think, right? I don't know. Wait, do all of my tests have their own? Yeah, exactly. They have their own thing. So I really don't know about that build thing here. So I guess I can do this, but like what? Main? Nah, it doesn't really work. That's not how I set it up. I really wanted to use the command line because it's more, quote unquote, more simple, but then... Wait, if I open my environment variable again, okay? Maybe I can just straight up say the CMake generator, right? So CMake generator. Okay, by the way, I'm just gonna mute myself for a quick second while I'm looking for this. I'm gonna try something. I'm gonna try to define the CMake generator as this one here, like arm none eab objdump.exe. Okay, let's see if this works. Now again, I just changed a environment variable, so I'm gonna have to restart VS Code. Yeah, I'm just gonna be opening the desktop again. Pico. Let's go here. Reopen. And now, I hope that this is going to work. I'm not sure at this point, but I hope. Okay, so let's put the Pico back into upload mode. And let's try, I guess. Pico build, no, not build. CD project button, yes, and then do. No, it doesn't work again. I'm not sure why. That's really annoying. CMake make program is not set. Okay, that's wait, so do RP CMake was unable to find a build program corresponding to Ninja. CMake program is not set. Okay. If I Google this. Okay, I'm gonna try something that I find on Stack Overflow. So something like this. You make program, and then here I'm just gonna add again the path to my CMake program. So this, like this. Oh yeah, they have to be /, I think. Maybe like this. Like that. And here, instead of being make.exe, it's gonna be this. Okay, all fun and games. Now, if I go ahead and do the system cannot find the file specified. Really? This? You can? Weird. Okay, why? That's pretty tough. I'm trying to understand. So running this or what do you mean? Pretty tough. How about no force then? Or something. What if I launch do again? Oh, okay, different output this time. That's what I thought. Yeah, they do say yeah, that's the thing. Like, I shouldn't even have to precise anything that I need to use as my CMake program or as my anything really. Because everything that I need for compilation, I think, should be set here. Kind of annoying. Dash CMake utils. It is. Then I include these. And in here, the program file Pico example. Is that really where it is? Feels a little weird, huh? Program file x86 Pico examples. There's a Pico examples here? No, there isn't. Set the install prefix. What are you even talking about? Oh, but that's not... Maybe these install scripts are not okay. Because they're on my other user. Oh, that's obviously that, right? I mean, that's probably the problem. I don't see where... yeah, I don't really see where the problem is, but... Like, if I go here in Pico, and instead I go in Pico SDK, and... I have these, didn't source, wait. I'm just gonna find where, like, these are. Like, CMake install.cmake and whatnot, like, all of these. I'm supposed to find them in this folder here. So, it doesn't really matter. Go SDK init. Okay, setting up platform, blah blah blah, that's cool. Pico SDK import. CMake can be dropped into an external project to help locate this SDK. Be included prior to project. That's cool. How do I make sure that the paths are okay? Because Pico SDK import.cmake, like it's really this one that names something incorrect. Because like this one, is there anything, like literally anything that truly seems incorrect? Well, okay. You know what? The thing is, there may be problems because this project that I currently have is a project that I put on my GitHub that I initially started programming on another user on my computer. So maybe somewhere there's a path that's incorrectly written, and because of that, it cannot find the files that it's supposed to, namely the Pico SDK, where possibly this is where all of the settings to compile CMake are written. So that's what I'm thinking is the main problem right now. Like, I can't see anywhere where in the code there's an actual problem, except the fact that like this just doesn't exist at all. It's a big lie. But apart from that, I mean, there's in a comment here something written about like this other user on my computer. So there may be stuff that's incorrectly set up. Because of the fact that this was, I don't know, this was set up for like a specific path on a specific user of this computer, and because I sent it to GitHub and re-downloaded it without anything, maybe there's a problem because of that. Also, the Pico SDK, maybe I didn't launch the init commands as I was supposed to. So I'll be debugging that on my own. I'm gonna end the stream here. And next time, you know, I really wanted to like do all of the steps with you guys, but I now realize that I probably should have tested that I could at least upload some code before then. But you know, I guess it shows you guys that everybody has problems with that. Even me, who managed to do a really nice setup with a single 2-letter command to upload code to the Pico, even that doesn't work. So yeah, next time I'm gonna be sure to show you the solution and to explain why it didn't work this stream. And next time we're actually gonna be getting to the objectives that we had for this stream. I'm gonna show you guys the objectives again. So firmware part 1, yep, it was debug led, button press, basic USB, and inputs to events. Once we're able to do the code, it's gonna be actually really fun, and it's gonna go really fast. The problem is just that we couldn't make it work, like the setup at all. So, you know, too bad, so sad. We didn't make it work this time, but I swear to God, next time, next time. And next time is possibly this Friday. So in 2 days from now, like maybe even in the afternoon. So like, you know, we can say a day and a half or something. I'm gonna be back and I'm gonna make sure that it works for sure this time. Okay, so I'm just gonna go through the steps of an initial setup, basically all over again, and making sure that it works. As soon as we can upload code, we're gonna be able to do some very interesting things. So see you guys next time, and I hope that you have a nice rest of your day.